Thank you very much. So Michał basically told our story before I can just go. So in our company, we're collecting money from club members and then pay it out to treasurers. So, you know, it's like reverse Robin Hood scheme where we take from the poor and give back to the rich. But actually people are willing to pay. They really like their sports clubs, but paying is sometimes just a chore. Like every month, the amount can change because, for example, this month there was a quarterly barbecue or something. So it's not even easy to set up a standing order. And we try to make it as easy for people to pay these subscriptions as possible. And because of that, we need to support as many payment methods as possible. And then it sometimes creates very different scenarios. For example, in Europe, it's very popular to use SEPA direct debit, where the merchant basically takes money from someone's accounts. But then, because that would be a little bit dangerous, the person has even a couple of months to reverse the transaction, no questions asked. So that sometimes creates very strange scenarios where someone pays and the payment is registered as accepted, and then before we even have the chance to pay the money to the club, the payment is reversed. So it creates many edge cases, and those edge cases are built into our business model. So that's why we actually started to think about using property-based testing. Property-based testing can generate a set of examples for us. However, when we first learned about it, we wanted to do it naively, just generate a set of different events that can happen. And actually, that's impossible, because if a payment isn't yet paid, we can't generate an event that it was reversed. Like, it has to be first accepted to be reversed. And that's how we came to stateful property-based testing. But actually, before we get to that part, I started talking to my colleagues about what do they know about property-based testing, especially in our local meetup group. And they said that property-based testing might be this thingy where you take a data structure and then you test it, but you actually don't, because in the end you still have to write unit tests. And I was like, why? What? Where did you get that? And we've tracked like common examples that you see during talks. So for example, in Lambda Days 2018, Jose was talking among other things about property-based testing, and the example was like the one on the slide, where you want to check string concatenation. And you generate the left string, right string, you concatenate them, and then check that the left one is in the output string and then that the right one is in the output string. So the problem with that test is that if, for example, we reverse left and right in our implementation, the property still passes. So like, it's a good example of a property because it's very simple and it fits on a slide. But on the other hand, it's not exhaustive. And to make really good properties, those should be exhaustive. You shouldn't be able to provide a buggy implementation and make your properties pass. Other example is very similar. Like, this is classic example in all the talks, that list reversal. So if you reverse a list twice, you should get an original list for any list of elements. And this also has the same problem, because if we supply identity function instead of reversal, the property still holds. So it's a good property, but it can't be the only one. So in the end, if you're not very familiar with property-based testing, if you just see the introduction talks, you might get the wrong idea about how property-based testing really looks like. And the success stories, the great usages of property-based testing are everywhere. For example, Quivik used to test AUTOSAR systems for Volvo. So AUTOSAR is this data bus in your car, and all the devices that you connect to it must really adhere to very strict protocol. So one of the things is that this protocol makes the device report its priority. And the usual way to test that was that every time they got a new device to accept, they needed to take all the existing devices and write some tests that check if the new device behaves correctly with all the other ones that were already accepted. And the more devices you had, the more problematic it became. So in the end, Quivik wrote a model for that, so that you can plug a couple of devices and then create a test that does basic actions and checks if the devices behave in the same way. And they found very curious scenario, because when you plug a special kind of radio and then you are turning the volume up, then your brakes didn't work. And that's something terribly specific. Like, no one would even try to think of that particular test. Probably they would just, I don't know, test brakes with play button or whatever, but it was only turning the volume up. The problem was that the endianness in the device was wrong. So it was thinking it's setting the lowest priority for everything, and the lowest of lowest priorities was turning the volume up. That overflew to the second byte, and then it reported itself as the biggest priority possible. So that is nice. It's nice to know that people that create cars use that kind of testing. Another example is LevelDB from Google. So this is a database that I'm not very familiar with, but I know the story how it was tested. So they had problem with ghost keys. Sometimes they were creating entries, and even after deleting them, something stayed in the database. Like, that was a buggy behavior, but it was very hard to reproduce. So they created a property-based test where they hit the database with different commands, one after the other, and then they found an example where it fails, and the minimal failing example had 16 operations. So this is a very strange number, because no one would write 16 consecutive operations in a unit test, but on the other hand, 16 is quite manageable if you need to debug it, because you can run them one by one and inspect state after every one of them. Another cool story is yet another talk from Lambda Days in 2016, and it's about testing Dropbox. So Dropbox is a little bit problematic to test, because if you have two computers that want to sync data in Dropbox, and you create file with the same name in both of them at the same time, those commands will be serialized in the Dropbox server, and one file will override the other. So in the end, the output is not deterministic. So what the researchers did is they calculated all the possible orderings of those commands. For each of them, they calculated what should be the output value, and then they checked what Dropbox did, and if what Dropbox did was in the set of those values, then the test passed. And they still managed to find places where you would likely lose your data if that happened, but you shouldn't. So that's another nice example. So all of those problems have this in common. They use state. And when I was preparing, I saw that there are many talks about basics of property-based testing and how to test basic data structures. Then there's nothing. And then there are those epic success stories. So like this talk is going to fill that gap. The agenda is that we will talk a little bit about basics, because we need to establish some common language. So we will talk about coming up with properties, about Oracle properties. Then we will jump to generators and shrinking. Then we will discuss how do we handle state in Erlang and Elixir. And all of those might seem unconnected, and it will be a little jumpy. But in the end, I will talk about how to build a model, and then all of those will nicely fit in place. And in the end, I will show an example of stateful test execution and what are the problems with it. So firstly, let's get back to this list reversal example. How could you test it so that it's really nice and tests that reversal can't be anything else than reversal? So instead of trying to come up with clever property like reversal of reversal, we could say that we take any list, then we take an integer k that is in the range of all the list elements, and then we check that element that is in the first list, kth, it's length minus kth on the output list. And this is a property that really checks reversal. So it's nice because we didn't re-implement anything, like this is the property, but still it's exhaustive, like we can test that in one property. And coming up with such properties isn't very easy. Sometimes I think that it might be even easier to come up with properties for stateful tests than it is for simple data structures. Next topic is Oracle properties, because sometimes we get to the point where we need to test something that involves randomness. So would you be able to come up with a good property for a hashing function? And that's actually an open question, because you could say that that a hashing function always returns an output of the same length. There could be a couple of properties, but they wouldn't be exhaustive. And that's why for stuff that involves randomness, you use Oracle properties. And an Oracle property just says that for all inputs, the output of your algorithm should be the same as an output of an Oracle. So, for example, in the case of hashing functions, we could use existing SSL implementation of OpenSSL implementation as our Oracle. And that way we can test maybe not if the hashing function is correct, but if it behaves the same as OpenSSL one that we trust. Okay, next topic is generators. So generators try to create data for your tests. Every time you test a property, you get up to a couple thousand examples, I think 1,000 by default. And the examples are not exactly fully random. So the first iterations use small data. For example, small integer is 0, and then bigger integers have either bigger numbers or start to be negative, and so on. For strings, for example, we can say that the smallest string is an empty string. Then the generator will try to add something, but again, it's usually smart, so it starts with only characters that are alphanumeric, and then it tries some other characters, and then it tries, for example, new lines and Unicode, and so on and so forth, until the string might get really big. But then, let's say that new line breaks our input. So after the test fails, proper is clever to shrink the data back. So we start with the case that was generated, and then we try to remove some letters from it so that it gets smaller. And every time, if the test still fails, we can continue shrinking the input. However, at some point we will get to a state where we cannot shrink the input anymore to have the test still failing. So that's our minimal counter example. And this is what really sets apart property-based testing, for example, from fuzzy testing, this shrinking phase. Because in the end, you will not only get an example, you will get the smallest example that breaks your tests. Okay, another jump, and it is about managing state in Erlang and Elixir. So if you imagine a gen server probably most of you know that GenServer behind the scenes is just a function that takes its state as an argument, so it's very explicit, and then in the end calls itself recursively with new state. In the meantime, there are more operations in there because it receives commands from external sources. Usually they involve also the caller PID. And then it needs to generate some kind of reply so that it can send it back to the sender. But what is really important in here is that this calculating of new state and reply can be a pure function when we abstract away this sending messages. So handle call defines your actual logic, and it transforms state from S1 to S2, and also calculates that answer. And this is very common pattern in Elixir, but also it will be used later in stateful testing. So yes, we're done with basics and we're going to the meat of the presentation. So stateful property-based testing is a little bit like Oracle properties, which is we firstly generate our input, and the input are commands that we will call on our system. And then we check if our tested system, after running those commands, has the same state as the model that we're supplying. So how do we create the model? We will do it on an example. And in Poland, we have the social security number called PESEL. And the PESEL has some nice properties that we will see in a minute. So it's just a bunch of digits where first 6 digits are the birth date, sorry. And then 4 digits are ordinal number. The Q digit, for the ordinal numbers, you have even access for females and odd access for males. And then in the end, Q is a check digit. And there's a caveat to it, because if someone was born after 2000, we add 20 to the month. So for example, if someone was born January 1st, 2005, his month is 21. And that actually broke a couple of existing systems back in 2000. So we will create a system that is buggy, and that the bug only shows if you add someone born after year 2000. So the example system will be patient database, which will have only 2 very basic operations. We will either search patient by its PESEL, or we will add a patient with PESEL name and surname. So the first question is, how do you create your model, and what is a model? So a model should be a representation of what your system does that is absolutely as simple as possible, but still can have the same set of operations. So for example, our database can have sharding, can operate over network on multiple nodes, but in the end, it's just a key value store. So we can use plain old Elixir map to emulate its state. So we will have a map that as keys will use PESELs, and then the value will be name and surname. To define a model in proper library, we need to implement 5 callbacks. So the first one is command. Command is our generator for stuff that we will call on our database. It uses state as a first argument, but in the first example, we will not use it, so we're ignoring the state. And then first command is call to a function patient database search with just one argument. The last thing is list of arguments, and we have a PESEL generator that we will not show in here. The other command is calling add patient with PESEL name and surname. And here, for example, we can say that name and surname are just plain old string generators. Then we need to implement the next state function, which is really similar to this handle call. And for searching anything, the state of the database doesn't change. So we just return the state as it was. But for adding a new patient, we will say that we are putting PESEL name and surname in that map. So that's it. Then we have two functions that for now will be unused. This is precondition, and precondition answers question, does the command make sense now? So previously when I was talking about reversing payments, if a payment isn't paid yet, then it doesn't make sense to reverse it. So such code will be put here in precondition. Postcondition answers the question, did it work? So we don't have to even come up with different properties for our tested system. Sometimes we just need to add a postcondition. This is the check that our system actually did what we want right after the command. Let's now see how this will execute. So we are searching for a patient. That is our first generated command. And because we're generating the PESELs randomly, we are searching a patient with PESEL P1. Then we're adding a patient with PESEL P2, searching for a patient with PESEL P3. Of course, they don't exist, so we get nothing in return. Then P4. And actually, the search space for PESELs is quite big. So it might be the case that even in our 1,000 runs, we never query for a patient that was actually added to the database. So that means that we're not testing if we actually have something in the database. To mitigate that problem, we can extend a little bit how do we call the database. So instead of having just two commands, we can have 4. Search for existing patient, search for missing patient, add new patient, and add patient with PESEL that already exists. And that doesn't translate directly to what we call to the database, so we will need some kind of wrappers. But let's see for now how that works. In the commands section, we will now use the state. We will need it to determine if we're searching for an existing or non-existent patient. So if we want to search for existing patient, we still use the same syntax where we call patient with search existing function. But then in the arguments, instead of generating a key randomly, we will say one of map keys state. So we're taking the keys from the state map that are our PESELs, and then we just choose one of the PESELs. So for example, a precondition for that function should be that there is at least one patient in our database initially. Otherwise, we just can't search for anything. So let's see how such guided execution looks like. We start with searching non-existent PESEL, and that should be always possible. Then we are adding a patient with PESEL P2. And then if we want to generate search for existing patient, we have only one PESEL in our state. So it has to be the PESEL P2. Then we're adding a patient with PESEL P3, and let's say that that one was born after 2000 and that breaks the system. We don't see it immediately, but let's say that next generated command is search for existing patient with PESEL P3. So now our test should fail because in our postcondition we can check that our model expects to find a patient with PESEL P3, but our system did not find it. So now proper starts the shrinking phase, and that is what is really important and why we needed all those callbacks. Because now we try to randomly take out some commands from those 5 in the beginning. So if we, for example, scratch the search non-existent patient, nothing bad happens. Like we can start the test again and see that it still fails. But let's say we now want to, by random, by accident, remove add patient with PESEL P3. What happens now is we're removing that command, and the next one can't be there because its precondition is not met, which means that we need to remove both of them at the same time. But if we remove both of them, then the test will suddenly pass. So we need to backtrack. That can't happen. Again, if we want to remove the add patient with PESEL2, we will automatically remove the search existing patient by PESEL2 because it's not in the state anymore. So in the end, we're left with a really minimal counterexample, and proper will display all the data, and we could probably see that the problem is with that kind of PESEL. So again, to recap how property-based testing works, we have first command generation that uses only our model, and it needs to be deterministic. So we only can use randomness that proper gives us. For example, one-off will select randomly one of the commands. But if in our model we do something with state that is random, then everything doesn't work. That phase depends heavily on precondition, because when we're generating the commands, we need to make sure that the precondition is met. Then the next phase is actual test execution, and that uses the generated calls with intermediate states for validation. And that depends more on postcondition. And the last phase is shrinking. If the test is failing, we basically rerun the test, but without generating the input. We just try to take commands from the initial input. So that's all there is to property-based testing. So there are absolutely epic success stories. And maybe it's not applicable everywhere, but where it is, it really shines, and there's nothing that we can substitute it for. But on the other hand, it requires considerable upfront investment. You need to first learn about it, then you need to build the model, and that's not always easy. Then you need to also maintain it. So you need to calculate if it's good for your particular example. And in the end, I want to recommend the book by Fred Herbert, Property-Based Testing with Proper, Erlang, and Elixir. It's absolutely amazing. It doesn't only show you how proper works, it also shows you how you should approach creating properties, how you should approach dealing with problems that I've just described. And stateful property-based testing is just one of many chapters that you can find in that book. So I can't recommend it enough. That's all from my side. I think we have some time for questions. Thank you very much.
Indeed, we do have time for questions. Are there any questions in the room?
Hi, thanks for a very nice talk. You mentioned maintenance of your props. How much work would you say it is compared to any other kind of test you have in your test suite?
So maintenance is maybe not the biggest cost. The upfront cost of developing model is quite high. And actually, for example, I wouldn't recommend using property-based testing at the start of your project. Again, it depends how well it is defined. For example, in our company, we had a couple of iterations where we, for example, created new rules when we were learning how banking actually works. Sometimes it's really quirky. And now that we have a stable model, it's nice to see if we have any edge cases. So like the initial cost is quite high, and we're actually not running property-based testing on production yet, because the initial investment also involved refactoring the code that we have previously. Like we started when Phoenix encouraged writing tests in a way where we add stuff to the database, then invoke a controller, and then check if correct stuff is in the database again. And that's not easily testable. So we're in the process of integrating it, and we still didn't get to the part where we run it. So yeah, the initial investment is quite big, but I believe that the more payment methods we add, the more complexity you have in your domain model, the more you can get from using property-based testing.
Thank you for the talk. So, a very concrete question. When you found some edge cases here with your property-based tests, do you put them into separated unit tests or no?
Yeah, you can do that. It depends on how will you set up your property-based test, because they sometimes run a little bit slower than your unit tests. So you may want to, for example, set up your CI to run them only once a day at scheduled time instead of with every branch and every release. So yeah, again, it depends.
So I have a question. My question is, would you do it again? Basically,
yes,
right?
yes.
After all you round, like, would you do it again?
I would do it again, especially given that I have the knowledge to do it properly right now. So the learning part also took considerable amount of time. And in the beginning, for example, I tried the approach with generating events randomly and just discarding them without the knowledge of how to use proper stateful testing. So when you know how to do it, for example, after reading that book, then it should be probably much more quick. And also, if you create your system with nicer boundaries than, for example, we started, and the business logic is separated from database logic, then writing your model becomes much, much easier. There's a question over there, I think.
When would you consider using model checking, for instance, instead of property-based testing? You know, the car example makes me think of, well, it's a typical case where you could have used model checking for example.
So I'm not that familiar with model checking. If there's anyone that is more familiar, then probably could answer that question better. But I believe that shrinking phase is really something that is only in property-based testing. And if that's the case, this shrinking part makes finding actual edge cases much easier, because in the end, like in the LevelDB example, you don't get a generated 100,000 calls and like do whatever you want with it, but you have this shrinking phase that really gives you minimal counterexample.
Hi, thanks for the talk. Very interesting. How much slower is it to run property-based tests comparing to a unit test suite, like in the ratio?
So our unit test suite has a couple of thousand tests right now. And because property-based testing sometimes generates 1,000 examples per property, then with that math, I can say that it depends again on the number of properties. But for stateful tests, sometimes it's just one property. And running, if they are not failing, then running them is fairly quick. Of course, they need to hit the database and so on, but that's quick in Phoenix and in Ecto. But when there's a failing example and it starts shrinking, then it basically needs to rerun the test again and again and again after the generation. And that part is sometimes slower because there's also backtracking involved. So in the end, if you don't have any bugs, then it's fairly quick to just run the property-based tests. And if you introduced a new bug, then it's probably worth waiting to check what was the problem.
We have time for one more question.
Thank you for the talk. There are many, or several libraries out there. There's Trick for Erlang. There's Xcheck that Elixir wraps Trick. There's Prop.ER. Do you think this has the best future, the most momentum, and which libraries have the best generators and shrinkers?
Yeah, so I think that the best and most feature-rich library is QuickCheck. But to get all the features, you need to pay for it. Proper also has some problems because of its licensing model. So, for example, as far as I understood, you can use it freely for development, but you can't create new code that depends on it as a production application. So these are licensing things that I'm not expert in. I'm not familiar with the other two you've mentioned. I know that when there was a time that Jose considered adding property-based testing to Elixir, they've created a wrapper or a library, but it didn't have stateful testing at all. So that was not implemented and we couldn't use it back then.
Thank you, Tomasz, and please give him a round of applause.
Thank you very much.